Hello everyone, hope you're doing fine. In this video, we're going to see 15 questions. So in the previous videos, it was just like a statement questions, but from this video, we'll have MCQ questions to make you more exam ready. So let's get started.
And before we start, I would really appreciate it if you could smash that like button, drop me a comment, and share this free program with anyone who might need it.
The first question is: a material has identical properties in all directions, then it is said to be what? We have already seen it is called as isotropic if it has identical properties in all the directions. Next question: the term nominal stress in stress strain curve for mild steel implies what? So we have two types of stress: true stress, also called as actual stress, then we have nominal stress. So what is nominal stress? So if we take a beam, say a cantilever beam, and if we say a UDL is acting on it, in reality we will be thinking, or in the design purposes we will be assuming that this UDL is acting on the centroidal axis. It is acting here, we'll assume. But in reality, that is in the true case, the loading will be throughout the section of the member. So from this you will be able to understand, I hope, the difference between nominal stress and the true stress. So in true stress, so it is simply like a stress formula. It is force divided by true area. In nominal stress, it is force divided by design area. So if we look at the options given, it is not the actual stress, because actual stress is different and nominal stress is different, and it is not the yield stress, and it is also not the stress at necking. It is simply the average stress. On to the next question. For metallic minerals, creep becomes an important consideration at what? So what is creep? Creep is the deflection or deformation in the material due to constant load over a period of time. And another thing we have seen in creep is that the maximum value of creep can be 0.0003. So coming to the question, the answer is half of the melting point. So when the metal reaches a temperature where it reaches half of the melting point temperature, then creep has to be considered. Next question, Clapeyron's theorem is associated with the analysis of what? We know that it is associated with the analysis of continuous beam. The other methods of analyzing a continuous beam is Carney's method, slope deflection method, you have stiffness method, you have flexibility method, you have so many methods. Next question, a rubber band is elongated to double its initial length. So if my length at 1 was L, then secondly my length becomes 2 times L. So what is its true strain? So if they have asked just strain, then you could have just gone to change in length by original length. But since they have asked true strain, we have another formula. True strain is equal to ln of L2 divided by L1. That is the new length divided by the old length. So substituting these values here, we can get that it is ln of 2L by L, and LL gets cancelled, so it is just basically ln 2, and the value of ln 2 is 0.693. So my answer is option B. But in the next question, the prismatic beam has uniform what? What is a prismatic beam? A beam which is something like this. This is called a prismatic beam. Where will we use this prismatic beam? We will use it to in the 2-point loading. Here you can see that prismatic beam, it has not only the uniform depth, not only uniform width, but uniform cross section. And strength, it doesn't matter here. Going to the next question. In case of pure bending, the beam will bend into an arc of what? So we know pure bending, neutral axis will bend. So it is an ideal case. So there it will resemble the shape of a or arc of a circle. Next question. If the modulus of elasticity is 0, the material is said to be what? So first, to understand the question, let us look into what is modulus of elasticity. So if I take a stress strain graph, then this slope is what I call the modulus of elasticity. So simply I have to understand what is the stress strain curve behavior for all these types. From that I will be able to find out which has zero slope. So any material that has zero slope, that we can tell that it has no modulus of elasticity. So let us look into the stress strain curve of all these materials. First, rigid. I am going to assume that rigid. I am going to assume the stress strain curve for an aggregate. So it will be something like this. We have seen in the previous videos the stress strain curve for almost all the materials. I hope you will be remembering it. So when we look at here, we can see that we have a slope. Therefore, it is not rigid. Coming to flexible, I'm going to take mild steel bar, so it's something like this. So again, I have my slope here, therefore it is not flexible also. Coming to elastic material, let me take an elastic material means what? Stress strain will be linear, and even when I remove a load, it will come back to its original shape, which means the slope is present, which means there is modulus of elasticity also. So coming to the stress strain curve for plastic, it is something like this. So here we can see there is no slope at all. So this means that if the modulus of elasticity is 0, it is plastic. Next question, in creep test, the following type of stress is applied to the specimen. So we know that in creep test, we go for uniaxial tension. Next question, free bar of length L. I'm stressing this point here, it is a free bar of length L, is uniformly heated 0 degree to temperature of T degree centigrade. Alpha is the quotient of linear expansion. E is the modulus of elasticity. The stress in the bar is what? It is simply 0 because it is a free bar. It is free to elongate. Only when there is a restriction, there will be stresses developed in the material. But since it is free to elongate, there will be 0 stresses. Next question. The test specimen is is stressed slightly beyond the yield point and then unloaded. Its yield strength is what? So for example, let me take a mild steel bar. So it will be something like this and like this. So this is my, till this it is elastic, this is my yielding point, and till here this is my ultimate strength, this is my failure. So they are saying that it is slightly stressed beyond the yield point. So this is my yield point. So I am going to assume that it is stressed till this point, okay? Till this point. Then it is unloaded. So again it is unloaded. Then the yield strength what? So we know that after the elastic point until the ultimate strength, we have something called strain hardening. We have seen already what is strain hardening in the previous videos. In strain hardening, the strength of the material keeps on increasing. So even after it is unloaded, the yield strength will only increase. So I hope you were able to understand it. So you can see that all the questions are like interrelated to my previous videos. I think it is better if you start from the first so that you can have a continuity. And going to the next question, the cup and cone type fracture occurs in the case of what? So if we look at a cup and cone type fracture, it is something like this. I mean, a material has broken, and after it has broken, it will be looking something like this. It has broken like this. This resembles a cup and this resembles a cone. So this is what we call a cup and cone type fracture, and this occurs mostly in ductile materials, that too round specimen of ductile materials. Next question, the materials having elongation less than 5% are considered to be brittle. In such cases, factor of safety is based on what? Again, in the previous video, we saw that factor of safety, it is associated with, of course, working stress method. And in working stress method, the working stress should be assumed in such a way that it should be less than the elastic limit. We will derive at a working stress in such a way that it is less than the elastic limit. So in the given material, we can see that the elongation is less than 5%. So let me take, this is like almost a brittle material. Yeah, it has been given it is a brittle material. So I can take my aggregate into account. I can take the stress strain curve of my aggregate. So if I look at the stress strain curve of my aggregate, I can see that after reaching the elastic point, it fails. My aggregate fails. So there is no elastic point at all. There is just limit of proportionality only. So since elastic limit, here we know elastic limit is the main point when it is coming to factor of safety. Since my elastic limit is not present, I am going to take my proportionality limit as my factor here. So the answer is, it is based on limit of proportionality. Next question, Young's modulus and the Poisson's ratio are given, and the modulus of rigidity, so it can be expressed as C or N or G, is asked. So we know the relation between all these things. It is E is equal to 2G into 1 plus nu, where nu is the Poisson's ratio. So they have asked for G, so G is equal to, substituting the values, I will get an answer of 0.4664 into 10 power minus 5 MPa. So going to the next question, in a homogeneous isotropic elastic material, the modulus of elasticity E in terms of G and K is what? So in the previous video itself, we have seen the relationship between E, K, G and mu, and how important that is. So if we know those four relations, then this question is a piece of cake. The relationship is E is equal to 9 kg divided by 3k plus g. This is how I kept in mind. So this resembles that answer. So the answer is option C. So with this we come to the end of the video. I hope you found this useful. If this is the first time you are watching this video, then you may not be at continuity. So I request you to watch it from the beginning, from the very first episode. So thank you so much for watching guys. I'll see you in the next video. Bye bye. Take care and stay safe.